had a couple days where we were missing class lectures, so I'm going to kind of quickly recap what we did here. Last Friday, which would have been November 1st, we're taking a look at imaginary numbers in kind of the first part of chapter 3. In general, imaginary numbers, mathematicians got frustrated basically because we couldn't find the square root of a negative number because nothing times itself will ever be negative. But we know through some of our other properties that we could factor out that negative 1. And so we know the square root of 144 is 12, but we just don't know what the square root of negative 1 is. So basically mathematicians made something up so that they could have the square roots of negative numbers. And so we identified the square root of negative 1 as the letter I, or the number I. And this is going to make up the complex numbers beyond our real numbers. So now we can call the square root of negative 144 12i. Okay, another thing that we've kind of looked at, and I think you have probably been taught in the past, is simplifying square roots. Honestly, I'm not going to grade us too hard on this, especially on tests, because I think it's easier to look at the square root of 27 and tell me that that's between 5 and 6 because it's between the square root of 25 and the square root of 36. But in some courses, you may be required to simplify this, so I want you to know how to do it. This can, again, get factored down, so it's the square root of 9 and the square root of 3, because 9 times 3 is 27. We know the square root of 9 is 3, so this becomes 3 radical 3, and it's now simplified. So that's some of those things you could do. Again, I'm okay with the square root of 27 because I think it's easier to simplify or to estimate what that is, and so you'll be able to identify that it's about 5 or 5.2, whatever. So next thing we're taking a look at is simplifying each expression to write them in the terms of I. Again, complex numbers are going to be written in the form a plus bi, where a and b are both real. And we'll put the complex part of the number second. So this becomes 2 over 2, which just simplifies as 1. And right now my button is tweaking out. Hold on. Okay, so this is 2 over 2 plus, and this is the square root of negative 4, so this is 2i over 2. And so we can simplify this as 1 plus I. Okay. So this becomes our simplified complex piece. Similar with part B here, we can simplify that as 6 over 3 plus, again, this becomes I times our radical 27, which we saw earlier. We can simplify that as 3 radical 3. So this becomes 2 plus, and again, if this is 3I radical 3 over 3, the 3's can simplify, so we get 2 plus radical 3, and then the I term comes last. So if we have it in the a plus bi term, a would be 2, b would be radical 3. Okay. There's a handful of other stuff we're doing here with our i's. Hopefully a lot of this is kind of familiar. If it's not, please make sure you come in and kind of ask about it. A couple pieces that I think are important are to take a look at things. Oh, just kidding, that's not the one I thought I was going to pull up, but we'll do one of these real quick. So this, I've got 5i times negative 3i. You can basically multiply your coefficients like we normally would. So this becomes negative 15 and then I squared. Okay, something to think about is if we've defined I as the square root of negative 1, if I square both sides, we see that I squared equals negative 1. So this number actually becomes a real number again. So then this could simplify into just 15. Okay. This becomes more important when we start to take a look at fractions that have I in the denominator. And we're going to see if we can actually Let me see if I can grab the one I was trying to pull up here. I think it's this one. Okay, so computing special products. Again, here, when we multiply this stuff out, it's two complex binomials that are going to get multiplied into a single real term. And so if I FOIL this out, we'll end up seeing that we get the 4 times 4, which is 16. 4 times 5 gives us plus 20i. 5 times 4 gives us negative 20i. And then negative 5 times 5i, negative 5i times 5i gives us negative 25i squared. And so what we notice is our two imaginary terms cancel with each other, positive and negative 20i. And then we will recognize that I squared can just become a negative 1, so that becomes plus 25. And so we'll get 16 plus 25, and this simplifies into one real term of 41. Where this is important and comes into play for us is when we're trying to simplify division with i's in the denominator, because we don't like having square roots in the denominator. And so let's take a look at something like this, where maybe I want to solve, oops, oh, things are freaking out, hold on. I don't know why my pen is tweaking right now. And it crashed. Awesome. Okay, reopen. See if we make this back. Sorry about this. That's what I get for doing this at 5:30 at night, right? Instead of doing it in class. Although I don't have a whole bunch of kids in the background making obnoxious comments. That's the plus. So we'll see if this will reopen. Okay, perfect. And so let's go back to that really quick. Okay, so we're going to try to simplify this. So 7 over 3 plus 2i. Right now, this has an imaginary number in the denominator, which is not something we typically want because it's got a square root in the denominator. So in order to get rid of that, just like we looked at, there's those special products. We're going to call this the complex conjugate. And so whatever that symbol is in the middle, we basically just flip it. So since it was plus, we're going to make it a minus. And if we multiply by that on top and bottom, it's like we're multiplying by a disguised version of a 1. So we're just multiplying by 1 here. We'll distribute across the top. So we end up with 21 minus 14i. And then in the denominator, you'll end up with 3 times 3 is our 9. We'll have the plus 6i and minus 6i, so those terms cancel. And then we'll have the minus the 4i squared, which 4i squared again is just like plus 4. So this simplifies out as 21 over 13 minus 14 over 13i. And now we're in our term a plus bi, and we're simplified. So hopefully this stuff will help us out, and that's the imaginary numbers.